So the first one is the Big Bang, that the creation of the universe was caused by a Big Bang. And when I said that word Big Bang to you, you probably reacted as the original person who coined it that name gave it in a kind of sarcastic sense. That you say, oh, that's not possible, that can't be. Well, it turns out that the Big Bang is now a law of physics. And very briefly, what it is that the universe was uh, contained, all the energy of the universe was contained in a very small region, a dot, a place where all energy was in this very small dot. And that theory came about because it was noticed in the mid 20th century that there were a whole bunch of galaxies that were flying away from us. So the universe was expanding. Now, if it's expanding now, it must have been closer in the past, and in the limit, it's all very close to each other at the beginning of the universe. That's where the Big Bang theory came from. So the idea was that then God then caused this region to explode, and it enlarged into the size of the universe that is today, which is extremely large. Now, one detail is that when that Big Bang happened, initially a whole bunch of that energy was converted into mass. Mass and energy are just the same thing in different form, a la Einstein's E equals mc squared equation. So that mass was formed, but then once that mass was formed, the remaining energy was still present as radiation, and that was then dispersed as the universe expanded. So that's the Big Bang theory. Now it's shown here that symbolically as a little dot that contained all the energy that ever exists in the universe is sitting in this small dot. And we know that its temperature was over 11 trillion degrees. I'm saying we know that. We think it was like 30 trillion degrees, but that's not something that can be validated or determined. But we do know that while this expansion occurred, when the temperature fell as the expansion occurred, when it reached 10.9 trillion degrees, that is the point at which no more mass can be formed. So the energy is sitting there just as energy. It blows up, it cools as it expands, and when it reaches 10.9 trillion degrees, all the mass that's ever going to be formed from some part of that energy has been formed. And below that temperature, as it gets cooler and cooler, then no more energy can be converted into mass. And that's an important point. So there is energy left over, and it's somewhere in the universe. Now, shown here is a Big Bang showing things flying apart here from the Big Bang, which means that everything was flying away from everything else. Both mass was going away and radiant energy was going away. And that is pictorially what the Big Bang might have looked like had we been able to see it. Now, the mass that was formed into stars and galaxies, and here's this bewilderingly large number of stars shown here on a photograph. So a lot of mass was formed, a lot of the energy that was in the initial Big Bang dot was formed into all of these stars and all of these constellations with masses of them, and there's just a bewildering large number. Our sun is only one member of a 500 billion star galaxy. So the Milky Way galaxy has 500 billion stars in it. Ours is the sun. And not only that, but they believe that there are 300 billion other galaxies. So it's an unbelievably large universe that is before us. So where is this background radiation? Have we found it? And the answer is yes. And it was found in upstate New York by a couple of IBM scientists who were setting up a radio telescope. A radio telescope that would receive radio signals from outer space for messages that were coming in that frequency range. While setting this up, they had difficulty getting rid of a small level of noise. Now, if you want to get signals from outer space, you want to make sure you start out with being noise free. And they observed that they had this noise. No matter what they did, they could get rid of this noise from outer space. They tried shutting down the freeway, shutting down the airport, working on Sunday morning when there was no one around. But the net result was that they were unable to eliminate this noise, and it was ultimately discovered that this was the background radiation from the Big Bang. Its temperature was measured to be 2.735 degrees above absolute zero. Remember that it was 10.9 trillion degrees at the instant of the Big Bang when no more mass was formed, and it's now 2.735 degrees above absolute zero, a very large reduction in temperature. These two men received the 1978 Nobel Prize for Physics for discovery, and it was the first of the two predictions that the Big Bang Theory made that was verified. So Big Bang Theory said this should have happened, and they found it. Now, the second prediction from the Big Bang Theory itself was that if you find this radiation, it should not be coming uniformly from all directions. If it were coming uniformly from all directions, that would mean that no mass concentrations could happen. There could not be any stars or planets. So it had to be non-uniform. Well, these two gentlemen measured it from the surface of the Earth the best they could, and they found, this is just meant to depict, that they found that there was everything was the same, and there was no preferred direction for anything that was observed from the surface of the Earth to the atmosphere, which was kind of disheartening. But up stepped NASA, and NASA set up the COBE satellite, which was only task was to measure this variation in cosmic background radiation direction, and lo and behold, they found distinct values for it, that this background radiation was not uniform, therefore suns and stars and planets could form, mass concentrations could be formed. And so this was the second Big Bang theory that prediction that was verified, and it made it into the Big Bang Law. The Big Bang Law now describes the existence of the universe as we see it today. Now the next slide is going to be a little bit hard to comprehend, but what the Big Bang radiation is a fluctuating light signal which has a certain frequency, and that frequency has changed over time as the universe has expanded. That is a clock. And here is the clock associated with that Big Bang radiation, and it's called the cosmic clock of the universe. And it's probably about the strangest clock you've ever seen. I've shown it here as if it were sitting on a table here with legs. But here is the first day that clock has run. The cosmic clock ran the first 24-hour day over this amount of time. The second day was over this amount of time. The third day, fourth day, fifth day, and sixth day were over equivalently shorter periods of time. So this is a strange clock, a clock that does not keep time or have time flow at the same pace all at once, during its lifetime. Instead, it varies, and it's actually speeding up over time from a very extremely slow pace to a faster pace now. And this cosmic clock has been ticking over 6 cosmic clock days for about 15 billion Earth years. Now that's, take reading some of the text and looking at the appendices even for you to be believing of this, but it turns out that this is a clock which from its perception and from its first calculation shows that there were 6 intervals of time on this clock since the Big Bang began, and those are equivalent to the 6 days that are reported in the book of Genesis for the creation period. Now note that the cosmic clock each day appears to be of a different length, and what that actually means that each hour and each minute and each second is different all the time as well. So it's a strange clock, but it is a clock that again resulted in the Nobel Prize being given for the finding of the radiation of the Big Bang, and it all makes physical sense together in terms of Einstein's theory of relativity, which is very difficult for most of us to understand, but it basically shows us that time passage is not constant everywhere in the universe. So here are those equivalent times, Genesis days 1 through 6, each of them 24 hours long, with all these things having different length. Day 1 is about 8,000 million or 8 billion years, 4 billion, 2 billion, 1 billion, a half a billion, those number of Earth years are equivalent to the 6 days that have ticked off on this cosmic clock. Now, let's have a check of that. What about for those time intervals that are shown for the cosmic clock? Here's day 3, day 4, 5, 6. For those days, we have fossils that have been discovered here on Earth for the oldest of particular types of fossils. Here in day 3, that's when the Earth and vegetation were created, and in day 4, it only says that vegetation continued to grow. No animals, only vegetation. These are all the oldest fossils of vegetation that have been found to date on Earth, and they agree with that time span. Only plants and plants of about that age. Let's look at day 5, in which water creatures. You can see here there's some water creatures. These are the oldest mollusks, the oldest bivalve, the oldest jellyfish. These are water creatures that were created on day 5, and the fossil record agrees with that timing. Here's the oldest fish, here are sea monsters, and here's the oldest bird. Those all appeared, the first of their species from the fossil record we have to date, appeared on that particular day. And finally, on day 6, we have the mammals and man. We have the oldest mammal being this particular type here that occurred at the beginning of day 6. So that means that the Big Bang Law, which describes 6 intervals of creation, and those 6 intervals of creations are totally consistent with what we observe here on Earth today.